Hello, welcome to OWAS Education YouTube channel. I want to first of all appreciate all my subscribers, those that are subscribed to my channel, and those that are yet to subscribe. I want to plead with you, implore you to subscribe and also share my videos and then like my videos and make your comments. Today I'm going to look into structural design. I'm an engineer, a structural design engineer. So I'm going to look at structural design this time around, and I'm dealing with design of slab. Design of slab. And when we talk about slab, slab is a kind of one of the structural elements in a building. We have slab, we have columns, we have beams. Although these are structural elements, and then the proper design of them will ensure the stability of the structure. So before I delve into design, I want to talk about the types of slab that we have. And then you have to be familiar with this kind of slab. We have solid slab. We have a roof slab. We have waffle slab. And also we have a flat slab. Now each of these type of slab has their own pattern of design, their own method of designing them. But the most common one is this solid slab. Now when we talk about solid slab, we are talking about a slab that has been supported by beams. You have beams that support the slab, either on the edges, either in between. So they are supported by a beam. So now we look at when you talk about solid slab, we have to look at the kind of slab we are going to design. We are looking at a simply supported slab. That is a simply supported slab, and that is being surrounded, be kind of supported by beams. So simply supported slab. And there's something you have to take note of, consider when you are dealing with a slab. It is loading. What and what is the slab supporting? What kind of load is the slab supporting? It's very important. And there are two types of load I want to talk about. The first one, dead load. Dead load is represented by GK. So when we talk about dead load, these are the load that are parts of the building. They are kind of inseparable from that building. They are just parts of it. And then those kind of load, number one is self-load and self-weight. The self-weight of the slab. Now, if you design a slab and cannot even support the self-weight, that means that slab will fail. When we say it fail, it means that it's going to collapse. It will not work. So that's what we are talking about. So a slab will be able to support the self-weight. The self-weight is the dead load, and then we have finishes. That is, after you have kind of construct your slab, you have cast the slab, and then you are not doing your finishing. Well, what do you put on top of the slab? Sometimes some people put tiles. So tiles is the finishes that comes on the slab. So finishes is one of the dead load. And also we have partitions. There's some kind of light partition being used to divide slab into different rooms. Maybe in an office now, after you have construct the building, you want to divide into different rooms. So there are some that use a kind of light partition just to divide. And then we also have block works. There are sometimes you put block works on the slab. We know that blocks will go as the edges of our slab, but even in between we have some block walls, and then the block walls will also serve as part of our dead load. And then we have another one we call imposed load or life load. It's either you call it an imposed load or life load. It's being represented by QK. Now, when we talk about the post load, we make use of what we call a BS code. In Nigeria here, we use BS code. And when you check BX 6399, 1996. This way, this BS code, this way is loading. The BS code there is this with loading. So you can check it out and you will see different kinds of load, and then the usage of the slab. The usage will determines the kind of load you put in. For example, now generally we make use of 1.5 kilonewton per meter square for residential building. Office building also have its own value, but then you need to know that in a particular floor, you can have different usage of your slab. For example, you can have, in a floor you can have a kitchen, and also you can have a store. Just for an example, maybe another room in the same floor, you have a place to put your machine room, and then some can put swimming pool in a particular floor. Now, what I'm trying to say is that what you are using your slab, a particular slab, the room, I mean the space that you create for a particular slab, that is, it can have different usage. Where you partition for kitchen, that slab, the value for that you are giving that place of kitchen will be different from the one you are using for your machine room. That is, the usage where kitchen and machine room, they can't carry the same value for their life load. They will be different because machine room has more weight than a kitchen. So depending on how you use depending on the usage of that particular slab, the room, depending on what you are using it for, so you put the life load there. So there are different life load you can put in a particular floor. So it's not just that you say this is a residential building and then you just put 1.5 for all the slabs that are there. So that one will be wrong. You have to know the usage of each of the slab partition so as to know the value you have to put there. And then I now come to load decomposition. That is, how do your load, how do they flow down from your slab? How do they come down? Now, you have load from slab, and then I told you we are talking on solid slab. From slab is transfer the load to the beams. Slab transfer from slab, it transfer load to the beams, and then there are ways in which these beams is being and the load from slab is being transferred. There's a yield pattern that is being followed. Is it a two-way slab? Is it a one-way slab? With the yield pattern, we can then calculate how the load flow from slab to beams. Maybe in other videos I will talk about this load and decomposition, the flow pattern of it, how it actually flow from slab to beams, and from beams it will come down to columns. From beams your load will come down to column, and then from columns it will goes down to foundation. Now in this foundation, now you want to know, is it a shallow foundation, is it a deep foundation? And then what determines this and this is the load coming on the foundation from various points of columns, and also your soil, how the soil test that you have done, the bearing capacity, what is the value, is the soil strong or is it weak? It will determine even the type of foundation you use. So from the foundation it comes to soil, and then this is where you are going to do your soil test. Your soil test is very important, and then here you are going to get your, what is it called, the soil bearing capacity. For the designer that want to design, you must know your soil bearing capacity, and also the soil test will show you your soil profile, that is the kind of soil at different level as you go into the ground. So this is just a kind of a brief introduction to the slab we are going to be looking at. I've talked about the type of slab we have. I've talked about the loading and the BS code to check your loading, the kind of the various life load that we have with their values, and also how load is being decomposed. So in the next video, I'm going to give you a drawing and also the design proper, and then how to design a slab. Thank you. See you in my next video.